The Galactic Alliance had always prided itself on being aware of every technological development across the galaxy. Their scanners were sensitive enough to detect even the smallest energy shifts on distant planets. Yet, when Earth appeared on their radar, most of the Alliance dismissed it as unremarkable. It was a young planet, home to a species still struggling to leave its own atmosphere. From orbit, Earth looked calm, quiet, and completely ordinary. The blue oceans, white clouds, and sprawling continents gave no hint of anything extraordinary beneath the surface dot at first. The readings were subtle tiny bursts of electromagnetic energy that seemed almost accidental. Alliance scientists studied them for months, but the numbers didn't make sense. They were far higher than what any known human technology should be capable of. Some researchers were curious and cautious, but the Council was quick to label it anomalous noise or natural phenomenon. No one in the Council wanted to admit that humans might be building something advanced. They were confident the species was still in its primitive stage. Despite the dismissals, a few researchers quietly continued their work. They noticed patterns that suggested intelligence. The bursts weren't random. They followed specific timings, frequencies, and strengths. The scientists compared the signals with known propulsion technologies, with long-range communication systems, and even with theoretical weapons designs. Nothing matched exactly, but something about the energy spikes hinted at a power far beyond what humans had achieved. Meanwhile, on Earth, humans were unaware of the attention they had drawn. They went about their lives in ordinary ways. Cities bustled with activity, children played in schoolyards, and millions of people went to work without ever knowing they were being observed from the stars. But in hidden laboratories and secret facilities, a small team of engineers and scientists worked tirelessly on a project that would later become the subject of Galactic. Fascination. These humans had been studying the principles of electromagnetism and mechanics for years, experimenting with ways to accelerate objects without explosions. Their early prototypes were small metal spheres sent along tracks using magnets. Each test was more precise than the last. Failures were common, but the team learned from every mistake. They didn't aim to create a weapon. Their goal was simple: to move things faster and more efficiently than conventional methods allowed. As the humans tested their early designs, Alliance scanners recorded the faintest traces of energy. The bursts were so minor that most observers ignored them. But a few researchers noted the pattern. "This isn't ordinary experimentation," one scientist whispered to a colleague. "If they continue at this rate, they might reach something remarkable within a few decades." Despite these warnings, the Council remained unconvinced. "Humans are unpredictable and emotional," one Council member said with a dismissive wave. "They lack discipline. Even if they stumble upon a new method, it will be chaotic and uncoordinated. There's no need for concern." The researchers tried again and again to make their case. They showed simulations, charts, and projections. They highlighted the speed of technological progress on Earth, pointing out that humans had gone from primitive flight to orbiting their planet in just a few generations. Yet their voices were drowned out by the prevailing skepticism. Most Council members wanted proof, not projections. They wanted humans to demonstrate power openly, not in secret laboratories hidden beneath layers of secrecy on a small, unremarkable planet. Back on Earth, the team of engineers worked in silence, not because they were hiding from the galaxy, but because secrecy was part of the process. Experiments of this nature required focus, careful measurements, and uninterrupted time. They spent hours calculating magnetic fields, testing different metals, and designing tracks that could withstand incredible forces. Each test was meticulously documented. Each failure was a lesson, and each small success built confidence. Outside the laboratories, life carried on as usual. Neighbors chatted, cars moved through streets, and radio signals traveled across continents. No one suspected that beneath the ordinary surface of the planet, humans were slowly achieving something that could eventually capture the attention of the entire galaxy. The contrast between mundane daily life and groundbreaking experimentation was striking. The team wasn't driven by recognition or fame. They were motivated by curiosity and problem solving. Their conversations were filled with equations, diagrams, and ideas about how to push boundaries safely. They discussed possibilities quietly, over coffee or during late-night shifts in dimly lit labs. They weren't thinking about impressing the Galactic Alliance. They were thinking about what they could accomplish together over time. The signals from Earth grew stronger, though still subtle compared to the scales observed in space battles or energy weapons. A few Alliance sensors caught the change and flagged it. The Council, once again, dismissed it. Probably just an improvement in industrial activity, one official said. Nothing to worry about. Humans are limited by their biology, culture, and technology. This will not escalate beyond minor anomalies. The researchers who had been warning the Council felt frustration building. Every prediction they had made was being ignored. They watched as humans moved forward steadily, unaware of the galaxy's scrutiny. They could sense that Earth was on the verge of achieving something the Council was not prepared to handle. But they also knew it was impossible to force the Council to act without incontrovertible evidence. In the meantime, the human team continued to innovate. They refined their rail light tracks, tested stronger magnets, and discovered new ways to reduce friction and energy loss. Objects accelerated along the tracks faster than ever before, achieving velocities that, if measured from orbit, would appear extraordinary. Each test was more daring than the last, though the humans were always careful to ensure safety. By the time the Galactic Alliance began to take notice again, humans had already moved beyond early experimentation. They had laid the groundwork for a system that could eventually transport objects across vast distances at speeds previously thought impossible. The humans themselves did not yet realize the full potential of what they were building. They saw it as progress, efficiency, and clever engineering, not as a technology that could one day challenge assumptions across the galaxy. Yet the signals continued to reach the Alliance. A few scientists insisted that the bursts were not mere experiments. They were the signature of something highly advanced. Some began to argue that humans might be developing tools that could rival the most sophisticated technologies known in the galaxy. The Council, however, remained divided. Many still clung to the belief that humans were too inexperienced, too chaotic, and too primitive to achieve anything significant. Even as humans celebrated small successes, the Alliance researchers quietly monitored every test. They saw objects traveling faster than any human-made projectile should, and they began to wonder how far the humans could go if they continued on this path. For some, the realization was thrilling. For others, it was alarming. The idea that an unassuming species might develop technology that could challenge the galaxy's expectations was almost unthinkable, and yet Earth remained calm. From the outside, nothing suggested urgency or threat. People went about their lives, unaware of the attention from distant worlds. They focused on experiments, improvements, and problem-solving. Their successes were quiet, personal, and methodical. They measured each achievement carefully, recorded every detail, and prepared for the next stage without any thought of impressing alien civilizations or winning galactic recognition. The contrast between the Alliance's worry and humans' simple focus was stark. One side was anxious, scanning for potential danger. The other side was calm, curious, and determined to solve problems step by step. It was the perfect combination for an eventual surprise, a quiet, unassuming species building something remarkable while the galaxy looked elsewhere. By the end of Part 1, the stage was set. Humans had made incredible progress in secret, and the Galactic Alliance had barely begun to grasp the scale of what was happening on Earth. The story of ingenuity, patience, and underestimated potential was only beginning. On Earth, life continued as usual. Cities were filled with people going to work, children laughing in schoolyards, and millions of ordinary activities taking place every day. From above, the planet looked calm and ordinary, completely masking the quiet revolution happening in hidden laboratories. Humans were making progress in a way that no one outside their small circle could. Notice the team working on the railgun technology had reached a point where the early experiments were no longer just tests. They were beginning to show real results. Small metal objects were moving at incredible speeds along electromagnetic tracks, faster than anyone had expected. Each success, no matter how minor it seemed, brought a sense of quiet excitement to the team. They didn't celebrate loudly or seek attention. They were focused on solving problems, improving precision, and understanding the limits of their technology. These humans were patient, creative, and remarkably disciplined. Unlike many other species in the galaxy, they weren't obsessed with proving power or dominance. They were motivated by curiosity, by the joy of learning, and by the challenge of turning complex ideas into reality. When a test failed, they studied it carefully, identifying every flaw and correcting it. When it succeeded, they made sure to understand why before moving forward. Meanwhile, the Galactic Alliance still monitored Earth, though their attention had become less consistent. Many in the Council believed the planet was harmless, thinking the humans' progress was slow and insignificant. They occasionally checked the energy signals, but no one expected humans to be developing technology capable of extraordinary feats. Most saw Earth as a quaint, emerging world, interesting, perhaps, but not a threat or a game changer. But a few observers continued to watch more closely. They noticed patterns in the energy readings that didn't match any known technology. The signals suggested acceleration and force beyond what humans were thought capable of. These few researchers began to argue that Earth might be developing something unusual, something that could one day alter the balance of technological power in the galaxy. Their warnings were largely ignored by the Council, but they remained vigilant, tracking every anomaly. Back in the hidden laboratories on Earth, the humans were unaware of the attention they had drawn. Their work was not secret because they feared being discovered. It was secret because meaningful progress required focus. The projects were delicate and precise. Every calculation mattered. Every magnetic field had to be perfectly aligned. Even a small mistake could ruin an experiment or damage expensive equipment. The team was diverse in skills and thinking. Some specialized in engineering, some in physics, and others in electronics and materials science. Together, they formed a network of minds that worked seamlessly. Ideas were shared freely, problems were discussed openly, and solutions were tested rigorously. Their work ethic and teamwork allowed them to accomplish things that would have been impossible alone. Their experiments had a rhythm. Metal projectiles would sit at the start of the track, sensors and computers ready. Magnets aligned, currents calculated, and a sequence of pulses programmed to perfection. When the system activated, objects accelerated with precision, guided by magnetic fields and controlled energy bursts. Each test produced data that fed into the next experiment, gradually increasing speed and efficiency. Even as the railgun technology advanced, the team remained humble. They didn't boast about their achievements or imagine immediate fame. They were curious about what was possible, and they wanted to understand their creation fully before showing it to the world. They measured results, logged every detail, and iterated constantly. In their minds, success was measured not by recognition, but by understanding and mastery. The human approach was unique. Other civilizations in the galaxy often focused on dominance or rapid technological leaps. They sought weapons, fast propulsion systems, or flashy demonstrations. Humans were different. Their progress was slow, careful, and steady, built on trial, error and learning from every experience. Their patience allowed them to reach results that, to outsiders, might have seemed impossible in such a short time got as the humans improved their technology. The Alliance's few attentive observers grew increasingly intrigued. The energy readings suggested something remarkable. Objects were moving faster, farther, and more efficiently than expected. There was a sophistication to the experiments that hinted at understanding, not random luck. The observers realized that the humans weren't just tinkering, they were systematically pushing the limits of their technology. Inside the labs, the humans focused on improving every component. Tracks were reinforced, magnetic arrays optimized, and control systems fine-tuned. They experimented with different projectile materials, adjusting weight and density to achieve maximum speed. They tested safety mechanisms, ensuring that even failures wouldn't result in catastrophic damage. Their work was precise, methodical, and entirely driven by curiosity and problem-solving. Sometimes, outside pressures interfered. Supplies had to be sourced, maintenance performed, and experiments paused due to minor setbacks. Yet the humans adapted quickly. They solved logistical problems with the same determination they applied to technological challenges. Every delay became an opportunity to improve understanding, plan more carefully, and refine their approach. The contrast between Earth's calm surface and the intensity of hidden experimentation was remarkable. While people went about ordinary lives, these humans were building a system that could one day reach far beyond their planet. It was a quiet revolution, almost invisible, yet with the potential to change perceptions across the galaxy. The Alliance observers began to take notes in detail. They documented patterns in energy bursts, measured the force of accelerated objects, and tried to predict how the humans might progress. Some were impressed, seeing ingenuity and skill that exceeded expectations. Others were concerned, realizing that the humans could develop technology faster than the Council anticipated. The humans, however, continued their work without concern for observers. They focused on results, not recognition. Their conversations revolved around problem-solving, efficiency, and understanding principles. They debated approaches, tested ideas, and learned from every small success or failure. Their goal was mastery, not glory. Over time, the humans achieved milestones that were quietly remarkable. Projectiles were moving faster than ever. Magnetic acceleration systems were optimized to reduce energy loss. Control systems allowed precise measurement of speed, force, and trajectory. Every achievement built confidence and pushed the team further. The Galactic Alliance. Observers began to realize the humans' potential. The energy patterns suggested the development of a system that could reach distances or speeds previously thought impossible for a species at Earth's level of technological maturity. Some began to argue that the Council should pay closer attention, while others clung to skepticism, unwilling to believe that humans could achieve so much so quietly. Meanwhile, life on Earth continued as normal outside the laboratories. Families gathered for meals, children played, and people went to work. There was no sense of urgency or alarm. The humans conducting the experiments appeared ordinary to anyone looking from the outside. Yet their patience, focus, and teamwork were quietly reshaping the future of their planet. The humans' approach to innovation was slow but steady. They learned from every error, refined every calculation, and tested every idea. They were methodical, careful, and patient qualities that would later allow them to surprise the galaxy. They didn't rush. They didn't aim to impress anyone. They only sought to understand, to solve problems, and to explore what was possible with their technology. Even as the Galactic Alliance debated the significance of the energy bursts, the humans continued building and refining their system. They were unaware that their work was drawing attention. They were unaware that observers were documenting each test, measuring each acceleration, and marveling at the ingenuity of a species so young in the galactic timeline. By the end of this stage, the humans had transformed their early experiments into a reliable system capable of impressive feats. The railgun technology was no longer theoretical. It was tangible, functional, and ready for more ambitious tests. The Galactic Alliance observers, finally beginning to grasp the scale of what was happening, realized that humans were quietly advancing in ways no one had expected. The story of human ingenuity, patience, and quiet determination was becoming clear. While the galaxy looked elsewhere, these unassuming humans were steadily building something extraordinary. Their technology, once underestimated, was starting to draw attention, and the Alliance would soon have to confront the truth. The humans themselves remained focused on the work. They were curious, precise, and patient. They didn't rush. They didn't worry about recognition or approval. They only sought to explore, understand, and improve. And in doing so, they were laying the foundation for a future that would one day astonish the entire galaxy. The Galactic Alliance had long underestimated Earth, treating it as a quiet, ordinary planet with limited potential. For years, they had monitored the faint energy signals coming from the planet, dismissing them as minor experiments or random anomalies. Many council members were convinced that humans could never achieve anything truly remarkable. They thought humans were too young, too emotional, and too unpredictable to develop advanced technology. But some researchers in the Alliance knew better. They had been quietly tracking the increasing energy patterns, noting every spike and anomaly. These signals suggested that the humans were developing something systematic, deliberate, and highly advanced. They weren't just experimenting. They were building a process that could eventually challenge everything the Alliance assumed about Earth. Despite this, the Council remained largely unconvinced. "They are humans," one member said. "They may stumble into something interesting, but their progress will be slow, chaotic, and limited. There is no reason for alarm." Others nodded in agreement, preferring comfort and assumptions over confronting the possibility that they had been wrong. Meanwhile, on Earth, the humans continued their work with quiet determination. The team of engineers and scientists was now moving beyond early tests. They had mastered the small-scale rail systems and were starting to explore more ambitious designs. Larger projectiles, longer tracks, and stronger magnetic fields were all part of their new experiments. Each step was calculated carefully, every failure studied, and every success meticulously documented. The humans did not work for fame or recognition. Their motivation was curiosity and problem-solving. They discussed ideas in quiet, focused conversations, often over late-night cups of tea or coffee. Their debates revolved around improving efficiency, increasing speed, and solving practical challenges. Each member contributed unique insights, and together they refined a system that grew more powerful with every iteration. Outside their labs, life appeared ordinary. People went about daily routines, unaware that some of their neighbors were quietly working on technology that would one day astonish the galaxy. The contrast between mundane life and groundbreaking innovation was striking. While humans lived ordinary lives, their minds were reaching far beyond what anyone had thought possible. As the humans made progress, the Alliance observers grew increasingly concerned. Energy spikes were becoming more pronounced, and patterns suggested a level of precision and understanding that exceeded expectations. Some observers argued that the humans might be preparing something significant, a technology that could change assumptions across the galaxy. Others still refused to believe it, clinging to outdated stereotypes of humans as slow and primitive. The debate within the Alliance grew more intense. Some researchers pleaded for more attention to be paid to Earth. "We cannot ignore these patterns," one said. "This species may be capable of breakthroughs we cannot yet predict. We need to study them closely before it is too late." But the Council remained hesitant. unsure whether it was worth the effort to divert resources from other priorities. Back on Earth, the human team was unaware of the discussions happening light years away. Their focus was entirely on the technology in front of them. They experimented with stronger magnets, longer tracks, and different projectile designs. Each modification produced new data, which they carefully analyzed and used to refine the system. The humans were patient and methodical, understanding that progress came from learning and adjusting. Not rushing toward results, not one breakthrough came when the team managed to accelerate a small projectile at a speed that far exceeded anything they had achieved before. The object traveled along the track with precision, maintaining stability despite the immense force acting on it. The humans studied the result carefully, measuring velocity, energy efficiency, and trajectory. They celebrated quietly, knowing that this was a crucial step toward realizing the full potential of their technology. The Alliance observers took notice. The energy readings from Earth now suggested that the humans had developed a controlled, repeatable method to accelerate objects at incredible speeds. This was not a one-time fluke, it was a pattern of progress. The observers began to realize the humans were far more capable than anyone in the Council had imagined. Inside the laboratories, the humans continued to refine their system. They experimented with different metals for projectiles, tested variations in track design, and optimized magnetic field alignment. Safety and precision were always priorities, even as the velocities reached unprecedented levels. The team was methodical, learning from every experiment and improving continuously. The humans' approach was fundamentally different from that of other civilizations in the galaxy. While many species focused on rapid progress, dominance, or flashy displays of power, humans prioritized understanding and mastery. They approached challenges with patience and determination, solving problems step by step. Their innovation was deliberate, careful, and cumulative, allowing them to achieve results that others might have considered impossible. The Alliance observers began to worry. They realized that the humans' progress could soon reach a point where the Council's assumptions would be completely invalidated. The patterns suggested that the humans were capable of applying their technology in ways that could have broad implications, transporting objects across vast distances, constructing orbital systems, or even altering planetary infrastructure. The potential was extraordinary, but the Council still hesitated to act. Meanwhile, the humans continued to focus on practical improvements. They tested longer tracks, larger projectiles, and more efficient energy systems. They calculated every variable carefully, learning from mistakes and adjusting parameters accordingly. Each experiment built confidence and expanded their understanding of what was possible. Outside the laboratories, life remained ordinary. Families went about daily routines, people worked, and children played. To any casual observer, nothing seemed unusual. Yet beneath this ordinary surface, humans were quietly mastering a technology that would one day surprise the galaxy. The juxtaposition of normal life and extraordinary innovation highlighted the uniqueness of the human approach. Calm, focused, and driven by curiosity rather than recognition or power, the Alliance continued to monitor Earth. Some observers became increasingly vocal, urging the Council to take the humans seriously. This species is progressing faster than anticipated, one warned. If we ignore them, we risk being surprised by technology that could alter the balance of power across the galaxy. Others dismissed the warnings, confident that humans were too slow and undisciplined to achieve meaningful breakthroughs. Back in the labs, the humans began preparing for larger-scale tests. They wanted to see how far and how fast their projectiles could travel. They adjusted magnetic fields, reinforced tracks, and tested energy systems. Every decision was based on careful calculations, safety considerations, and previous results. The team's patience and methodical approach allowed them to make steady progress, step by step, without risking catastrophic failure. The contrast between humans, quiet diligence, and the Alliance's growing concern became increasingly clear. While the Council debated whether to pay attention, humans were steadily moving toward achievements that could one day surpass the expectations of the entire galaxy. Their focus on understanding, learning, and careful experimentation allowed them to advance in ways that were almost invisible to the outside world. The humans' success was not accidental. It was the result of curiosity, discipline, teamwork, and a relentless drive to solve problems. Each experiment built on the last, and each small success created a foundation for larger breakthroughs. Their methodical approach ensured that progress was consistent, measurable, and reliable. By the end of this stage, humans had reached a point where their railgun technology was no longer just an experiment. It was a functioning system capable of accelerating objects at remarkable speeds with precision and control. The Alliance observers finally recognized that the humans' achievements were real, deliberate, and potentially transformative. The Council remained divided. Some members argued that humans were now a species worth monitoring closely, capable of advancing faster than previously imagined. Others clung to old assumptions, unwilling to accept that Earth had become a center of technological innovation. The debate highlighted the gap between perception and reality, a gap that humans themselves remained blissfully unaware of. The humans, focused on their work, continued to refine and perfect their system. They experimented with new materials, tested different energy levels, and pushed the limits of their railgun technology. Their curiosity and determination drove them forward, step by step, building a system that could one day change the way objects moved in space and perhaps even alter the galaxy's understanding of Earth's potential. By the conclusion of this part, the stage was set for something extraordinary. The humans had achieved remarkable progress, and the Galactic Alliance was beginning to realize that their assumptions had been flawed. The quiet, patient, and disciplined work of a few determined individuals had set the foundation for technology that could one day astonish the entire galaxy. The day had finally come for humans to test their railgun technology on a larger, more ambitious scale. For years, the team had been perfecting the principles, running countless experiments with smaller projectiles, shorter tracks, and controlled conditions. Now, they were ready to see what their system could do when pushed to its limits. The atmosphere in the laboratory complex was a mixture of anticipation, concentration, and quiet excitement. Unlike most civilizations in the galaxy, humans didn't rely on public demonstrations or flashy displays to prove progress. They focused on practical results and careful observation. Today's test was no different. Every detail had been planned, every calculation checked, and every safety measure in place. The team gathered around the track, watching screens filled with data, sensors, and real-time measurements. Their expressions were serious, but their eyes reflected the excitement of reaching a new frontier. The projectile was placed at the start of the long track. It was carefully balanced, designed to withstand the forces it would experience. The magnetic systems were charged, the energy currents calibrated, and the control software prepared to regulate acceleration precisely. The humans spoke in calm, measured tones, coordinating every step. There was no hurry, no panic, only focus and precision. As the test began, the first surge of energy coursed through the magnetic arrays. The projectile lifted from its resting position and began to move along the track. At first, it accelerated slowly, a steady buildup of force that allowed the system to maintain control. Sensors recorded every detail: the speed, the trajectory, the energy efficiency, and transmitted it to the computers for analysis. The humans observed silently, checking each reading, adjusting parameters in real time. Within seconds, the projectile reached speeds that had previously only existed in simulations. It moved with extraordinary precision, maintaining stability along the entire track. The energy readings from Earth's surface spiked, sending signals far into space. The Galactic Alliance, monitoring from orbit and beyond, detected the sudden surge. Many observers were startled. These readings were unlike anything they had ever recorded from Earth before. The humans, they realized, had gone far beyond ordinary experimentation. The team on Earth didn't fully comprehend the attention they had drawn. To them, this was simply the next step in understanding their technology. They were focused on data, on measurement, and on refining the system for even greater achievements. The work was meticulous, and they treated every success as an opportunity to learn. Not a moment for celebration. As the projectile completed its run along the track, the team carefully measured the results. Every variable was logged: speed, acceleration, energy consumption, stability. They noted anomalies, identified areas for improvement, and discussed potential adjustments for future tests. Their methodical approach allowed them to see patterns and solutions that would have been impossible without careful observation and analysis. Meanwhile, the Galactic Alliance scrambled to understand what they were witnessing. The energy bursts and acceleration data suggested a level of technological capability far beyond what they had believed possible for a species like humans. Some observers were fascinated, marveling at the ingenuity and precision. Others were concerned, realizing that humans could soon develop applications that might affect not just their own planet, but potentially the balance of technological power in the galaxy. The Council convened emergency meetings. Many members argued about whether humans posed a potential threat or simply represented an extraordinary, yet harmless, technological achievement. Observers presented data and simulations showing the speed and control humans had achieved. The Council debated, divided between those who wanted to intervene and those who believed humans should be observed quietly, without interference. Back on Earth, the humans continued to refine the system. They experimented with longer tracks and larger projectiles, increasing both the distance and velocity. They adjusted magnetic fields, tested different materials, and optimized every part of the process. Their patience and discipline allowed them to make steady progress, avoiding errors that could have set them back or caused accidents. Each new test brought small surprises. Sometimes the projectile moved slightly differently than expected, or sensors recorded anomalies that had to be corrected. Every challenge was an opportunity to learn. The humans approached each problem with calm determination, analyzing the data, discussing solutions, and implementing improvements. Their teamwork was seamless and their focus unbroken. The project was not about impressing anyone. It was about understanding the technology, mastering its principles, and pushing boundaries safely and steadily. Unlike other species in the galaxy, humans did not rely on intimidation, displays of power, or dramatic demonstrations to assert their progress. They focused on mastery, knowledge, and practical application. As the humans continued, the Alliance observed growing signs of sophistication in the technology. The energy readings suggested that the humans had developed a system capable of accelerating objects with precision, efficiency, and repeatability. It was not just a weapon. It was a tool, a means of moving objects across distances with control and safety. The potential applications were vast transportation, construction, resource management, and even space exploration. Despite their growing awareness, the Alliance remained cautious. Many members of the Council struggled to adjust their assumptions about humans. They had long believed that Earth was insignificant, that its inhabitants were too primitive to achieve meaningful technological breakthroughs. Now, those assumptions were being challenged by data, by real-world demonstrations, and by the clear evidence of human ingenuity. The humans, however, were unaware of the attention. Their world remained grounded in ordinary life. Families went about their days, schools operated, cities functioned as usual. It was a remarkable contrast. The same planet that appeared ordinary to the galaxy was the home of groundbreaking technological achievement. Humans were quietly rewriting the limits of their own capabilities, without ambition for fame or recognition beyond their small teams. During one of the larger tests, a particularly impressive achievement occurred. The projectile reached a speed and distance never before achieved on Earth. The team carefully recorded every measurement, analyzed the results, and discussed possible improvements. They spoke calmly, their excitement contained within the careful, methodical work that had become their habit. The Alliance observers, however, were astonished. The energy spikes, precision, and control were unlike anything they had expected from humans. Some observers began to worry that the species had advanced faster than anyone had predicted. Others marveled at the ingenuity, realizing that humans had not just built a machine, they had developed a system that demonstrated understanding, creativity, and discipline on a level few species had achieved so quietly. Even as the humans continued, they maintained their focus on the immediate task, improving the system. They experimented with timing sequences, adjusted energy input, and refined the track alignment. Every test, successful or imperfect, was treated as a lesson, not a spectacle. Their approach was scientific, methodical, and deliberate, and it allowed them to achieve results that would surprise anyone observing from a distance. By the end of this series of tests, the humans had achieved a milestone that would later be recognized as the first large-scale demonstration of their railgun technology. From their perspective, it was simply the result of patience, collaboration, and careful experimentation. From the galaxy's perspective, it was the moment when Earth could no longer be ignored. The Council of the Galactic Alliance met again, analyzing the new data. Some members were still skeptical, clinging to outdated assumptions. Others, however, recognized that humans had surpassed expectations. The debate was heated, reflecting the tension between old beliefs and new evidence. Some argued that humans should be studied closely. Others feared that the species' potential could one day disrupt the balance of power. On Earth, the humans moved on to the next phase, unaware of the debate occurring across space. They refined the system further, tested larger projectiles, and explored new applications. Their motivation remained curiosity, understanding, and progress. They were focused on what could be achieved, not on impressing anyone. The contrast between human focus and galactic attention was striking. Humans, quiet and determined, continued their work. The Alliance, astonished and concerned, scrambled to understand the implications. While humans saw their experiments as practical steps forward, the galaxy saw them as a revelation, a sign that the underestimated species might be capable of extraordinary achievements. By the conclusion of this part, humans had successfully completed the first major public-scale test of their railgun system. The Galactic Alliance, which had long ignored Earth, could no longer dismiss the planet or its inhabitants. The stage was set for the next phase, when the implications of this technology would begin to be understood more fully, both on Earth and across the galaxy. The Galactic Alliance could no longer ignore the evidence. The energy readings from Earth were too consistent, too precise, and too extraordinary to be dismissed as random experiments or minor anomalies. Observers reported repeated demonstrations of acceleration and control, far beyond anything previously thought possible for humans. The Council, which had long underestimated Earth, was now forced to confront a reality they had avoided for decades. The atmosphere within the council chambers was tense. Members argued heatedly over the significance of the findings. "We cannot continue to ignore this," one researcher insisted. "The humans have developed a system that exceeds the capabilities we predicted for them. If we do not act, we risk being surprised." Others responded with skepticism. "They are a young species," one council member said. "They may have developed something interesting, but it is unlikely to pose any real challenge to the galaxy's technological balance. We should observe, not panic." Despite the debate, some council members were growing increasingly anxious. They reviewed detailed reports, simulations, and energy readings, realizing that humans had achieved precision and control in ways the Alliance had not anticipated. The observers who had tracked Earth closely warned that humans' progress was systematic, deliberate, and capable of rapid advancement. Their caution was based on patterns that suggested not just experimentation, but understanding. Humans were not stumbling blindly, they were learning, improving and innovating with methodical precision. On Earth, the human team continued their work, entirely unaware of the discussions happening across the galaxy. Their focus remained on refining the Railgun system, improving accuracy, and testing larger projectiles over longer tracks. They carefully measured every result, logged all data, and analyzed each test with patience and precision. Each experiment built upon the last, steadily increasing their knowledge and understanding of the technology. Unlike many civilizations in the galaxy, humans were not motivated by recognition or power. Their progress was driven by curiosity, problem-solving, and a desire to understand the principles behind their success. Failures were expected and welcomed as learning opportunities. Successes were quietly noted, analyzed, and used to refine the system further. This methodical approach allowed humans to achieve results that seemed almost impossible to the observers watching from afar, as the humans pushed the limits of their railgun technology. The Alliance could no longer ignore the potential implications. Observers presented evidence showing projectiles reaching unprecedented speeds with remarkable accuracy. These readings suggested that humans were capable of applying their technology in ways that could have profound effects on transportation, construction, resource management, and even planetary defense. Some members of the Council began to feel a sense of urgency. If they continue at this pace, they will soon achieve capabilities that could rival our most advanced systems, one observer warned. We need to take this seriously. Earth is no longer a minor planet. Its inhabitants are advancing faster than we expected. Others resisted, arguing that humans lacked the coordination, discipline, and experience to develop the technology into anything that could truly matter on a galactic scale. Back on Earth, the human team remained focused on the immediate task at hand. They tested longer tracks, heavier projectiles, and more complex magnetic sequences. They adjusted currents, refined control software, and experimented with new materials. Each test provided insights that informed the next iteration, and the system gradually became more precise, efficient, and capable of achieving higher speeds. The humans' approach to problem-solving was unique. They collaborated openly, shared knowledge freely, and maintained a patient, disciplined mindset. Their discussions were calm, rational, and focused entirely on the work at hand. There was no desire for public recognition or galactic acknowledgement, only the satisfaction of understanding, creating, and improving. The Alliance observers, however, were growing increasingly concerned. The energy spikes detected from Earth were no longer subtle anomalies. They were clear demonstrations of technological capability. The observers realized that humans had not only understood the principles of electromagnetic acceleration, but had also applied them with remarkable precision and control. The system was reliable, repeatable, and capable of handling larger projectiles than anyone had anticipated. The Council debated the potential consequences. Some members feared that humans could one day develop technologies that might challenge the balance of power in the galaxy. Others argued that humans were unlikely to pose a threat, insisting that the species' lack of experience and coordination would prevent them from using their technology for anything beyond exploration or practical applications. Despite the debate, the Council finally agreed to send a small delegation of observers to Earth. They would study the humans directly, gather detailed data, and evaluate the potential impact of their technology. It was a cautious step, but one that reflected the growing recognition that Earth could no longer be ignored. Meanwhile, The human team continued to advance their technology, entirely unaware of the incoming delegation. They focused on testing higher energy inputs, refining magnetic alignment, and optimizing projectile design. Each test was carefully measured, and the results were meticulously recorded. The team discussed the data, identified areas for improvement, and planned the next steps with methodical precision. The humans' quiet determination and methodical approach continued to contrast sharply with the Alliance's sense of urgency. On Earth, the work was steady, deliberate, and focused entirely on learning and improving. The humans were not motivated by power, fear, or recognition. They were driven by curiosity, creativity, and a desire to solve complex problems. This mindset allowed them to achieve results that the observers found astonishing. As the humans expanded the scale of their tests, the Alliance delegation arrived in orbit. They observed from a distance, carefully monitoring energy readings and trajectories. They were astonished by what they saw: projectiles moving with incredible speed and precision, systems operating efficiently, and humans coordinating complex experiments with remarkable discipline. The delegation realized that the humans had not only achieved technological breakthroughs, but had done so quietly, without drawing attention or creating conflict. Their progress was deliberate, thoughtful, and systematic. The humans had mastered principles that many in the galaxy had assumed would take centuries to develop. The observers reported their findings to the Council, emphasizing the sophistication, precision, and reliability of the human technology. Some Council members were incredulous, struggling to accept that a young species could achieve such results without external assistance or intervention. Others recognized the significance immediately, acknowledging that humans had quietly become a technological power in their own right on Earth. The humans continued their work, unaware of the attention or the debates across the galaxy. Their focus remained on testing, learning, and improving. Each experiment provided insights that allowed the team to refine the system further, increase projectile speed, and optimize efficiency. The humans' methodical approach ensured steady progress and minimized risk. Even as the scale of their experiments grew, the contrast between humans and the Galactic Alliance was clear. Humans approached innovation with patience, curiosity, and discipline. They solved problems step by step, learning from every success and failure. The Alliance, by contrast, reacted with concern, speculation, and debate, struggling to understand the unexpected capabilities of a species they had long underestimated. As the human team prepared for the next phase of testing, the Alliance realized that they had underestimated Earth for too long. Their assumptions about the limitations of the species had been flawed, and now they faced the consequences. A young, determined species had quietly developed a technology capable of surprising the entire galaxy. Despite the growing attention from the Alliance, humans remained focused on their work. They continued to refine the Railgun system, explore new possibilities, and test the limits of their technology. Each experiment brought them closer to understanding the full potential of what they had built. Their approach was consistent, deliberate, and disciplined, ensuring steady progress without unnecessary risk. By the end of this stage, humans had demonstrated their capability to operate a highly advanced railgun system reliably and efficiently. The Galactic Alliance had finally acknowledged the significance of their progress, and the stage was set for the next phase, understanding the broader implications of this technology and the potential future of humanity in the galaxy. The humans, meanwhile, remained unaware of the broader attention. For them, the work was about curiosity, exploration, and solving problems. They were methodical, patient, and precise. Their quiet determination, teamwork, and disciplined approach had brought them to a point where they could achieve extraordinary results, all while the galaxy watched in awe. The humans had been working quietly for years, But now the time had come when the scale of their achievements could no longer be ignored. Their railgun technology had reached a level of precision, power, and reliability that was truly extraordinary. Projectiles moved at incredible speeds, controlled with perfect accuracy, and capable of feats that few other species could imagine. On Earth, the team continued their work, focused on refining every detail, unaware of the magnitude of the attention they had drawn across the galaxy. In orbit, the Galactic Alliance observed in awe. The energy signatures from Earth had become impossible to dismiss. The Council, which had long underestimated humans, was forced to confront the reality. This young species had achieved technological mastery in a way that no one had predicted. The members of the delegation watched as the humans conducted increasingly ambitious experiments, each more impressive than the last. Some council members were shocked, unable to reconcile their long-held assumptions with the evidence before them. "How is this possible?" One whispered during a meeting. "They are supposed to be a primitive species, yet they operate with precision and intelligence that rivals the most advanced civilizations in the galaxy." Others were more analytical, examining data, running simulations, and calculating the potential implications of the humans' progress. On Earth, the human team was focused entirely on their work. Their experiments had become larger in scale, testing heavier projectiles and longer tracks. Every detail was monitored, every calculation double-checked. The team discussed results calmly, shared insights freely, and iteratively improved their systems. They were not motivated by recognition, fear, or power. They were motivated by curiosity and the challenge of mastering something complex and new. The contrast between humans and the Alliance was stark. Humans worked quietly, methodically, and with patience. The Alliance scrambled with concern, debate, and speculation, realizing they had misjudged a species they had long ignored. The human success was not sudden or chaotic. It was deliberate, carefully measured, and built upon years of persistent effort. As the humans prepared for a particularly ambitious test, they did not realize that the Alliance had begun to discuss direct contact. Observers wanted to understand the humans' intentions, to assess whether their technology could be a threat or simply a demonstration of ingenuity. For now, the humans remained blissfully unaware, focused on the practical task of accelerating a massive projectile along a newly designed track. When the test began, the projectile moved with extraordinary speed and control. Magnetic fields guided it flawlessly, while sensors tracked every millisecond of its movement. The humans monitored results in real time, noting energy efficiency, stability, and precision. They discussed minor adjustments and improvements, each step informed by careful observation and analysis. From orbit, the Alliance watched in disbelief. The projectile's speed, accuracy, and the human's ability to control it far exceeded any expectation. The data indicated not just technical skill, but an understanding of physics, engineering, and systems integration that was exceptional for a species so young. Members of the Council realized that humans had quietly become a technological power in their own right. The humans were still unaware of the full scope of their accomplishment. For them, it was simply the result of careful work, collaboration, and curiosity. They did not pause to think about how others might perceive their achievements. They were focused entirely on mastery. Each success, each adjustment, each improvement was measured, understood, and documented. The Alliance Council convened an emergency session. "We have underestimated Earth for too long," one member admitted. "Their technology is no longer primitive. They have achieved capabilities we did not believe possible. If we fail to acknowledge this, it could change the balance of power in the galaxy." Others agreed, though some still hesitated, clinging to old assumptions about humans' unpredictability and inexperience. Back on Earth, the humans pushed forward. They experimented with even larger projectiles, testing longer distances and higher velocities. Each test was carefully monitored, every parameter adjusted for precision and safety. They worked with calm determination, solving problems step by step, learning from every result. Their approach was methodical, deliberate, and effective, qualities that had allowed them to achieve so much without drawing attention. The contrast between Earth and the Alliance was striking. On Earth, humans worked quietly, patiently, and creatively. Across the galaxy, the Council struggled to comprehend what had been achieved. They had assumed that Earth was a minor, developing world, but now the evidence was undeniable. Humans had developed a technology that was reliable, efficient, and scalable. They had turned theory into reality, achieving what few civilizations could. Some observers in the Alliance began to advocate for caution. "We must study humans carefully," one said. "They are not aggressive, but they are capable of extraordinary things. We cannot predict how quickly they will advance or what applications they may develop." Others saw the potential for collaboration, recognizing that humans could contribute to the galaxy in ways previously unimaginable. Meanwhile, the humans prepared for the largest test yet. They had designed a projectile of unprecedented size with a track capable of handling enormous forces. Every sensor, magnetic coil, and control system was calibrated to perfection. The team coordinated their actions carefully, speaking in calm, precise tones, their focus unwavering. When the projectile launched, it moved faster and farther than any previous test. The humans monitored data, adjusted controls, and documented every result. The system worked flawlessly, demonstrating not just raw power, but remarkable precision and control. The achievement was a culmination of years of patient work, experimentation, and collaboration. From orbit, the Alliance observers were stunned. The energy readings and performance exceeded every projection. Humans had not only mastered the principles of electromagnetic acceleration, but had applied them with a level of skill and understanding that rivaled the most advanced civilizations. For the first time, the Council was forced to admit that their assumptions had been wrong. "This is not just an experiment," one member said quietly. "This is a breakthrough. Humans have achieved mastery of technology that could have significant implications across the galaxy." Others nodded, recognizing the truth in the statement. The Alliance had long underestimated humans, but now it was impossible to ignore their potential. On Earth, the team continued their work, unaware of the impact their achievements had on the galaxy. They focused on refining efficiency, improving accuracy, and exploring new applications. Each success built confidence, each failure provided insight, and each experiment expanded understanding. They were driven by curiosity, creativity, and a desire to solve problems, not by ambition, recognition, or power. The contrast between humans and the Galactic Alliance had never been clearer. Humans approached challenges with patience, discipline, and collaboration. The Alliance, by contrast, had relied on assumptions, skepticism, and outdated perceptions. Now, faced with undeniable evidence, they were forced to confront the reality. Humans were capable of achieving extraordinary things, quietly and deliberately, without seeking attention. The final report from the Alliance. Delegations summarized their findings. Humans had developed a railgun system capable of extraordinary speed, precision, and control. The technology was scalable, reliable, and versatile, with applications that could extend beyond Earth to space exploration, transportation, and resource management. Humans had achieved mastery of principles that were considered advanced even by the galaxy's standards. On Earth, the team continued their work as if nothing had changed. They refined their systems, tested new configurations, and explored possibilities. They were curious, patient, and methodical. They were not concerned with how others perceived them, only with understanding and improving what they had created. By the end of this chapter in history, humans had quietly, but unmistakably proven their capability. The Galactic Alliance, which had long ignored Earth, now acknowledged the true potential of the species. Humans had demonstrated ingenuity, discipline, and creativity on a scale that few had expected. Their technology was a testament to persistence, collaboration, and the power of curiosity-driven innovation. The story of humans and their railgun technology became a turning point. The Alliance could no longer dismiss Earth. They had underestimated a young species, and the consequences of that underestimation were clear. Humans had shown that quiet, deliberate progress, guided by curiosity and collaboration, could achieve results that astonished even the most advanced civilizations. And through it all, the humans remained focused on the work itself. Their achievements were the product of patience, discipline, and a relentless desire to explore and understand. They had changed the galaxy's perception of them without ever intending to. In the end, it was not aggression, spectacle, or ambition that had brought humans recognition. It was curiosity, ingenuity, and the quiet mastery of a remarkable technology.